So in module 13, I'll take the liberty of passing on to again the problem of Neumann's optimal allocation in the context of stratified sampling. There are some issues to be taken up, and I thought it is best to take it up in the form of a question. And followed by that, we will have some more thoughts on general sampling designs, construction of homogeneous linear and burst estimators, at least a feel for that beyond the Horvitz-Thompson estimator. We only had some specialized estimators like Deshler's estimator and Murthy's estimator in the context of PPS sampling. With or without, we had Hansen-Harold estimator, etc. But we did not quite get a feel for the most general scenario of a homogeneous linear and burst estimator, how to get it in a given situation beyond the Horvitz-Thompson estimator. So there are some issues that should come, and I thought in this module we can take up two questions, one based on the Neumann optimal allocation and the other based on the notion of general sampling design. So in module 13, I'll take the liberty of passing on to again the problem of Neumann's optimal allocation in the context of stratified sampling. There are some issues to be taken up, and I thought it is best to take it up in the form of a question. And followed by that, we will have some more thoughts on general sampling designs, construction of homogeneous linear and burst estimators, at least a feel for that beyond the Horvitz-Thompson estimator. We only had some specialized estimators like Deshler's estimator and Murthy's estimator in the context of PPS sampling. With or without, we had Hansen-Harold estimator, etc. But we did not quite get a feel for the most general scenario of a homogeneous linear and burst estimator, how to get it in a given situation beyond the Horvitz-Thompson estimator. So there are some issues that should come, and I thought in this module we can take up two questions, one based on the Neumann optimal allocation and the other based on the notion of. Shubhra, we will start with the question number 1, which is based on stratified random sampling. Let's see.
In stratified simple random sampling without replacement, to work out Neumann's optimal allocation of the total sample size across different strata, we use standard formula. It is quite reasonable that sometimes for some stratum, the sample size NH opt exceeds the corresponding population size capital NH. Do you agree with this kind of situation arising? If it so happens, how would you visualize this in the algorithm of generating a two-way table? And how would you resolve this issue using the algorithm? Work out an example to this effect.
It says that is it ever possible that by following Neumann's optimal allocation formula, which says NH opt equal to small n WHSH over summation WHSH, the kind of formula that we use left and right, is it possible that by using this kind of formula, small NH opt, that will exceed the corresponding population size capital NH? And if that happens, what do you do? How do you incorporate that scenario in the two-way table that has been generated? Let's see, we can take up the same example as is used in explaining the computational algorithm for implementation of Neumann optimal allocation formula in the text. So somewhere we had this table, we referred to 7 strata, and every row corresponds to one stratum. The p values, which are WHSH, pH equal to WHSH, those p values are in decreasing order, and we worked out for every stratum, we worked out the quantity pH over n times n minus n plus 1, k times k plus 1, and that is how the table looked like. And for any given overall sample size little n, all we did is handpick that, make a top selection handpicked, and that is what was done here. We had handpicked top selection pre-reacting the number small n. Note that in the above, it was tacitly assumed that the stratum sizes are sufficiently large. We did not bother about to see whether whatever sample we are getting from every stratum, whether that is right or wrong. So we pretended that the population sizes are sufficiently large, At least those are comfortably placed well above the NH opt values. But there may be situations wherein some of the stratum sizes are small from practical considerations. So this time let us specify the stratum sizes. So we have got 7 strata. Let the actual stratum sizes be 6, 9, 20, etc., giving a total of 100. And as per the algorithm that we had, we computed the NH opt values and they turned out to be 8544333, giving a total of 30. And we find that we are sensing a danger right in the first stratum because NH opt is 8, whereas NH in the first stratum is only 6. So there is a problem here. Is it understood that we took up the blind application of the formula for getting Neyman optimal allocation, and that results in N1 opt equal to 8, whereas capital N1 equal to 6. So there is a genuine problem here. That is the kind of problem that we are referring to. What to do? Here we come across a situation where N1 opt equal to 8 more than 6, which is N1. What should we do now?